I imagine lots of you probably know me. My name is Fatemeh, and I'm a lead application engineer in EDRMEDESO. I haven't put any slides about company or EDRMEDESO introduction. Recently, we have some skill presentation kind of learning that they said avoid to put it, but I'll try to nice and very quick. I will tell about my company and also what I'm doing there. EDRMEDESO is one of the Ansys channel partner and are helping companies to reach their innovative ideas with simulation without they are going through lots of risk of the measurement and cost of the measurement. So I'm mainly responsible for electronics softwares and any high frequency and sometimes even low frequency. But today I'm going to talk a little bit about space and how simulation can help people that are working in the space sector. In next few slides, I will cover some critical area that are essential in space, like communication and data transfer, phased array, beam steering technologies, and performance of installed antenna, satellite co-site, radar cross-section, and how ESD analysis is play an important role in the space, and also thermal analysis. And I'm going to introduce one of the tools that it's mainly system toolkit SDK and how that tools can be combined with all the areas that I mentioned in one tool. I was planning to give a like kind of live demo for SDK, but it just because of the quite limitation of using the tools here, I just used some ready video at the end of the presentation. So antenna. Always it's, I mean, all of us, we heard about antenna. Antenna are quite essential, essential in space application. Because of course they are enable communication, they enable data sharing, they give us a way to navigate and also remote sensing. But in the space, because we are dealing with the quite big kind of distance and a very big distance, they are even play a more important role how we can communicate between a very big distance in the space. Without antenna, space mission would be very limited, and it just I can say a like kind of example. The antenna in the space for us is like a phone line for us in the Earth. That it just gives us the way that we can communicate with the space, and we can get a right information from the space, and we can make sure that everything works well. But of course, not all of the RF engineers or people in the RF area, they are antenna specialists. And designing the antenna is sometimes it's going to be quite challenging. There are lots of criteria that you need to consider, from gain, directivity, bandwidth, polarization, feed type, and also if you are going to use it as the steering. What we can have in the, as you can see, there are several types of antenna for different application, for different environment. But what we have a ready kit that you can, even though you are not expert in the antenna design, there is more than 50 available topologies of antenna there, and you can just with the giving the kind of requirement that you are looking for, the material or any information that you have, you can quickly, in less than a few minutes, you can create your antenna. So this is for the situation that people, they want to see the performance of antenna or they want to integrate it with their system, but they are not necessary the antenna expertise. But for the people that they are antenna expert, still, instead of they put lots of time to design the antenna, they can use this tool. And in space, mainly we are not dealing with the single element antenna. Lots of time we are dealing with the phased array because we want to steer the beam and we want to communicate in the different directions. And again, generating a phased array, quite big phased array antenna, and if it wants to go through the a prototype route, it's going to be very costly, it's going to be very difficult, and if any requirement is failed, you need to repeat everything from the beginning. Again, in the HFSS, there is a kind of tool that give you automatic kind of creation for the phase array, and it's quite flexible in the term of making a different shape of phase array. Not necessarily all the phase array is going to be rectangular, not necessarily it's going to be very symmetric. You can even design in the different way. And when we are designing the antenna, when we are even fabricate and do the prototype for the antenna, the performance of antenna is much different in the situation that you are install it in the place that you are going to use it. Because of course in antenna, the main parameter in the antenna is the electromagnetic. And the electromagnetic field around the antenna can be affected with any kind of material or any other object around it. And when we are going to use the antenna in certain kind of electrically large place and we want to install it, we need to make sure that how that a structure is going to affect the antenna performance. And this is some things that in HFSS there is a tool called SBR Plus, and that is give you that opportunity that you can build your antenna and install your antenna to the target, that no matter how big the target is, you can implement it and run the simulation and see the effect of near field, far field situation with the installed object. Again, it can be a satellite, for example, because today I'm talking about the space. It can be the satellite that you are going to implement it. And the SBR, because we are dealing with the very large scales environment, is no longer is using the FEM method, is using SBR is the for shooting and bouncing ray. So these techniques give us the same accuracy that we have in the FEM, but in the very quick way for that large scale. Another important analysis for the antenna or satellite is the satellite co-site analysis. So the satellite co-site analysis is the process used to evaluate and mitigate electromagnetic interference and electromagnetic compatibility, which we call it EMI and EMC. That they are raised when we have multiple satellite or system in one share physical platform, or they are operating in the very near distance to each other. So with the tool, we can prepare our geometric channel model and radio modeling, and then we can find the issue and do the analysis. In very brief here, we can say that with the simulation, we can, for satellite foresight analysis, we can manage system performance data, we can simulate any EMI or EMC effects, and then we can identify the root cause of those effects, and then we can resolve those issues. Another parameter, another analysis that is important, which is just the previous presentation, Alex mentioned about it with the, I believe, better details than what I written here. It was about radar cross-section, and it's how we measure that device can be detectable or by radar. So this is another thing that, again, in space, we need to consider for satellites, how they are, for example, about their location, how they can be detectable with the radar. So with the simulation, we can design advanced radar cross-section for very complex structure, and we can define a material characterization, which they are very important to effect to the radar cross-section, and also we can have a quite fast and accurate modeling. Another important analysis for space. I'm sure as the most of you RF engineers or you're dealing with the RF worlds, that how ESD electrostatic discharge can be affected in the lab or any kind of IC chips that we are using. The very small sparkle which can burn or make the failure of the system. But in space, there's no atmosphere to protect the spacecraft from radiation. So the charge build up from the radiation, and they can't dissipate because the spacecraft are not grounded. So a spacecraft design must properly mitigate charge accumulation and dissipation on the spacecraft surface and inside component. If they can't really analyze the ESD in the space, that very small sparkle in the lab for the IC, it can be make a very huge sparkle in the space and make the system failure. So again, this is a tool that you can do all the analysis before you are doing your prototype, or even after your prototype, before the satellite goes to the space. There are some standard design for ESD, which is the standards normally put place with NASA or ESA, and they are trying to protect the satellite from this ESD problem. So with the simulation, you can easily pass those standards before your product goes to the market or satellite or space. Again, I'm sure that you are familiar with how that thermal can affect to the system failures, how if, for example, the power amplifier, any like system, small system in the earth, if the thermal management was not considered, how it's going to affect to the failure of the system. Again, it's going to be more critical in a space application, because we are dealing with the quite harsh environment. If we are not very well defined to thermal management, it can be either make the satellite burn or overheat or freeze. So all of this is effect to the performance and can cause the satellite failure. Again, this is the kind of tool that you can bring a very big geometric, all the satellites with all the details inside the satellite. You can do the full thermal analysis. And the nice things about it is this is going to be in parallel and two-way communication with the EM analysis. For example, if you are using HFSS for EM analysis, this thermal desktop, they are working like two-way communication to each other. So any EM loss that we have, in the same time, you can see the effect of EM to the thermal, and same opposite as well. So the thermal analysis, we often don't have a very accurate data about it when we want to define the, for example, analysis. There is lots of challenge that we have. And for example, there are sometimes the heat flew through the contact or insulation. They are quite not uncertain about the data. So in the simulation, we can have a kind of optimization, that even that we are not very clear about all the data, we can optimize it, and we can have a different kind of scenario and analyze the different scenario based on the uncertain kind of data. So the workflow for the thermal analysis together with the other tools is, normally we have some design concept, not necessary that we are going to have all the data about the design, and then we can add any thermal connection, any heat loads, any radiation boundary condition. For example, for satellite, one of the things is that we are dealing with the heat from the sun, and you can model all of these things, and you can see the effect of, for example, where is the position, how far is from the sun, and how the thermal is going to affect. And then you can add other data, any other structure or data that you have, and finally with the combination of, for example, EM simulation and the thermal, you can have a full result. There are several applications for a thermal desktop, and you are doing a kind of big structure thermal analysis, which is of course for satellite thermal loading, for a space launch, for other kind of application, which is today mainly our focus on the space. So as I said, it's in a space situation, we are not dealing with one physics. We are not just dealing with the electromagnetic. We are not just dealing with the microwave or radio frequency. We are dealing with the thermal We are dealing with lots of mechanical issue. It can be a shock, it can be a stress, it can be a vibration. And we are also dealing with the optical situation in the space. So this is the kind of situation that we can have a full story, full scenario in one package. And you can bring all of this in the package that now I'm going to show you a demo called SDK, System Toolkit, that you can make the scenario and bring your satellite, all the details in the satellite, do the thermal analysis. Again, the data is communicate between all the tools, all the physics from mechanical, optic, electromagnetic, and SDK. You might heard about other thermal simulations that are available, for example, ice pack or mechanical. But sometimes people asking, okay, what's happened? What is the thermal desktop exactly? What is the ice pack? What is the difference between them? The main difference is in the other tools that normally we are able to do the thermal analysis for the small structure. We can put one RF system in, for example, ice pack, for example, or any other thermal tools. But the difference is here, as we have a similar kind of things in the EM simulation. I said SBR, you can put a very big structure, very large electrical structure. Here is the same. The main things is you can build a very large electrical scale environment and put all the details inside and do the simulation. And the final things that I'm going to show you and talk about it is the SDK, which is System Toolkit. It's quite interesting kit because it's show you and do the analysis somehow for the real world scenario, a real situation that you have with all the satellites in the space with a different location and everything. So you can do lots of different analysis. You can model your RF system and do the analysis. You can do the integration interface, and you can customize your application and your scenario. As I said, there's integration, thermal simulation, electromagnetic simulation in the SDK. So in this video, again, I was planning to show you the live demo, but accept this ready video. This is the SDK tool, and as you can see, you can either give the map. For example, you can give the Cambridge map with all the buildings and everything. This is, for example, of course, we want to show some satellite performance. You can use it as the 2D or 3D, and then you can change a different unit or time zone based on which location you are, and you can add a different objects like satellite, different planets, different even vehicle in the ground, missile aircraft, and different kind of scenario you can create here. And pardon? Okay, and then after, for example, you put all the different object and things like satellite you want to have, you can, for example, define a location and place that where they are going to be, for example, be there. And also you can define a like kind of target area, which area you want to do, for example, analysis on that area. And then you can do the calculation, for example, what is the distance between the, for example, that satellite to this area, how far is going to be, how long is going to take until, for example, when satellite is going through the orbit, how is going to reach there. And then, for example, you can also use a different planet, of course. You can use, as I said, a different scenario. So one of the, just trying to, okay, this is, for example, a calculation for line of sight between the some target place to the satellite, for example. And then, sorry, I'm just trying to put it a little bit further. And you can see that, for example, show you exactly where the satellite, which orbit satellite is choose to the moving, how it's going to, for example, miss line is going to be launched, and also the vehicle on the ground. One thing that I'll try to show in this video, I couldn't put it a little bit faster, but what things that I'm going to show based on the location that you choose. For example, you can choose the different countries or different places. You can see the active and not active satellite that currently there are, for example, is around that area, and you can see the all list of the satellites. And then, for example, you can choose between them and see which one is active at the moment, which one is not active. And you can build your, for example, the antenna that you design in the HFSS. You can bring it in the satellite. You can see the, for example, you can define the satellite as the transceiver or the receiver, how the antenna is, or, for example, any base station on the ground. And you can see the communication between the transceiver and receiver from the satellite to the ground. You can do the calculation, see all the data on the plot, and also you can see the 3D kind of animation as well. But all of this is based on the real data, and the software normally, I think, twice in the day, if I'm not mistaken, update itself based on the which satellite is, for example, in that area, and which one is active, which one is not active. Okay, this is, for example, we allocate one area, one, for example, country, and then it's update based on all the satellites that already they are active and not active. You can choose, for example, just show the active ones, and then you can see which one is moving from which orbit and how they are working. And then after this, for example, one of the things that I try to show here, again, it's, for example, I choose one of the satellite and I consider it as the transceiver. I can add the any customized antenna on this one, or I can use the ready antenna in the library. And then this is the ground, the receiver in the ground, how the, for example, the from the ground they are going to communicate to each other. And you can see all the data, not necessarily just the animation, but you also can see the 3D graph and animation as well. So that's my presentation. Thank you very much, and